Okay, good morning, guys. You see right here, I have a entanglement here between the Q0 line and the Q1 line. Entanglement here between the Q3 line and the Q4 line, right? So there's two different separate quantum entanglements happening here. Right here, you see it, CX or control not, control X. Q0 is connected to the Q1 line, and the Q3 line is connected to the Q4 line. With a control not, you see the Hadamard here at Q0, the Hadamard here at Q3, right? So this is the code, and these are the gates. And you see the Hadamard gate is at the Q0, which is here. See the Hadamard is at the Q3, which is here. And then you see the control not gates connecting from the circuit line 0, 1, and the circuit line connecting between Q3 and Q4 circuit lines, okay? So what we're gonna do is I'm gonna run a job through a real quantum computer to read and scan the gates that I've created, and we're gonna see what it comes out with. Let's see what the real quantum computer finds when it scans this and gives me a readout. All right, so what real quantum computer or lab am I going to use? I think on the last time I did this, I used Brisbane, Australia. This time I'm going to use Kyiv. I think Kyiv is in the Ukraine. I think that's somewhere in Europe. So I'm going to use that quantum computer. And I'm going to go and do 1,024 shots. 1,024 shots means it's gonna run this quantum algorithm that I created in gates. It's gonna run it 1,024 different times, and it's gonna give me an average of what it finds. All right, so that's what we're gonna do now. Let's see. 1 second. If it's open, it may not even be open today. Let's see. Let me see something. Let me see if it's that quantum. Let me see if it's even open for me to run. I may not be able to run it. Okay, yeah, I think it's able to run. Oh, okay, I gotta measure it. I made that same mistake last time. So we're gonna put a measurement here. We're going to put a measurement here. And the reason why is because these two well, you have a Hadamard gate here on this line here, and you have a Hadamard gate here. So you need a measurement here to measure what gate is on this line here. And for the second two qubits that are entangled, you need a measurement gate here to measure this Hadamard gate that's on this line here. But you also need a measurement here, and you need a measurement here, right? You need measurements on all of these different places because 1 second. 1 second, hold on, I may be making a mistake. Hold on a second. Make sure I get this right. Might be 1 second. Take a look at this. Let's take a look at this. Let's see. me refresh this page. I want to make sure I get it right. Make sure I get it right for you guys. Let's see here. Just give me a second. Let's see here. Let's take this off. Let's take this off. I wanna see something. I think this IBM platform is kind of running kind of slow. Sometimes this platform runs slow, so it doesn't read out the changes you make right away. So it kind of throws you off. Let's see. Yeah, I think that's what's happening, because it shouldn't be giving me this readout. It should be a lot faster than this. It's acting slow. It's acting very slow. It should not be giving me these readouts. Slow. I hate when it does this. Let's see. All right, so okay, so hold on. Let's do this real quick. I think I know why it's reading slow. So what we're gonna do is we're gonna put these measurement gates, and then we're just gonna go through and get this reading from this this quantum computer in Kyiv. We're just gonna go with it. All right, so let's do this. We're gonna run the job. You see, it's running. I had a little problems with the website running a little slow. IBM's platform, sometimes that happens. It runs a little slow, a little behind, delayed when you change up and you make switches to gates and your operations, but I think I got it working now. Okay, so let's see. Okay, so let's look at this. Let's take a look at this. Okay, so this Hadamard gate, right, on Q0 line and the Q1 line, they're entangled. So it was measured, right? It was measured by the quantum computer that I sent out. It measured the results. It gave me an outcome. It gave me backup results and stats. All right, so what does the Q0 line read? Well, the Q0 line is these first numbers for the large bars. Don't worry about the small bars, because those didn't give us the big average. You're only going by the 4 large bars, because those are the averages that gave us the greatest outcome, the greatest readout and preference, right? So for this one, you got a 1 for the first number. For the first number here, you got a 0, and that equals the Q0 line here. For this large bar, you got a 1 and you got a 0. So you got 2 1s and 2 zeros, which means that this Q0 line is entangled because you got 2 1s and 2 zeros, right? You got 2 1 states and then 2 0 states. Now let's look at the second number, which represents the Q1 line, right? Which is connected to the Hadamard gate. They're both entangled. This has a 1. This one has a 0. This has a 1. This is 0. So that means the Q1 line is entangled as well. It's in a state of entanglement, right? So now let's go to Q3 line, which be the fourth number going from right to left. That's a 1. This is a 1. This is a 0. And this is 0. So those two, so that Q3 line is entangled. That tells me it's entangled with another qubit. And then let's go to the number 5, which is the Q4 line. You have a 1. You have a 1. You have a 0 and 0. That means this is entangled as well. This is in a state of entanglement, right? So this is what the quantum computer from Kyiv, I think that's what, Germany or Ukraine, this is what the quantum computer read back to me, the results and the stats and the information. You see the job is completed, and this is what the information is sent back to me from that lab, from the gates that I sent it. So that's the end of this video. I thank you for watching.